now. So today we're gonna dive into 12 for more of our work with 2-dimensional and 3-dimensional shapes. But today we start talking about the relationship between 3-dimensional shape and 2-dimensional shapes. So, sorry, I thought they were pinging my room. A chef needs a piece of cheese for a new recipe that he's creating. So, if you've ever...
Ah, yes, the perfect slice every time. I guess that's why I'm the top cheese around here. I said, I guess that's why I'm the top cheese.
Ha! Good one, Chef Gordy.
Kitchen humor. You've got to love it.
Chef Gordy has a pretty lame sense of humor. But, so has anyone ever used a cheese slicer? Yeah, right? So it's like a little wire, but it just slices straight down through your shape. Now, if you took that wire at any point in the block of cheese, you could slice through it. What we're doing today is thinking about what happens when I slice through shapes. Mainly, right rectangular prisms are what we're going to start with. Then we're going to go get a little bit more difficult. So if I slice through right here, and I could kind of, if I saw through the shape, I'd get a slice of cheese that is right here. Now, what would the dimensions of that slice of cheese be? Now, we are going to assume it's 2-dimensional. If this was really cheese, could it be 2-dimensional? No. No, it has to have thickness. But for our purposes, we don't care about the thickness. We just care about what shape it becomes. I have the same point people right here. All right, what's the length and width?
4 inches and 4 inches.
Yeah, 4 by 4, right? Because if this was 4 and that was 4 and that's where I cut, I now have 4 there and 4 there. So I see that if I cut vertically through it, I get a 4 by 4. But now what if I said, we're going to make a really long sandwich, and I'm going to start cutting horizontal slices through the cheese. What would that slice measure, Thomas?
That slice measures 4 by 13.
4 by 13, how'd you figure that out?
Because there's a 4 there and a 13 there.
Always look at the sides that you're cutting through. Notice I cut through the length, the long, like the front. It's 13, so I'm going to have a 13. Notice I cut through the side right here. That is 4. So that is going to give me 4. The 4 of the height doesn't matter because I don't care about the height. I only care about how long it was, how deep it was, or how wide it was. So whenever we're looking at these 2-dimensional slices, always look at what sides did I cut through. Those are the dimensions I'm going to take. Or like what sides did I cut parallel with. You can kind of think about. Eminor, did you not leave me a copy of notes? Jeez. I thought you were a professional.
Not really.
I did, thank you. So, our big discussion here. We have 2 different ways that we can slice vertically. I can go from the front to the back. How else could I slice vertically?
Back to front.
Well, but that'd be the same thing, right? It'd be the same slice. So I could do a slice this direction or side to side, right? I could turn my slice and go this direction. So my first vertical slice right here, it should be showing. Don't know why it's not. So you have it on your paper already showing your first vertical slice is from front to back. Then my second vertical slice is left to right. And my horizontal slice, is there a way to get 2 different sizes of horizontal slices in a shape like this? Whether it's a rectangular prism or a cube or whatever it is. Eli, is that a hand or are you just pushing against the wall? Trying to make sure the wall doesn't fall down. So right here, we're looking at this horizontal slice. Is there any way to get different, like what happens if I shift it up or down? Does that change the size?
Yeah.
If I shift where I sliced, up or down, if I slice higher on the block or lower on the block, will the size of my slice change? No, because it is only going to use this length and that width. The height doesn't matter. So I want you guys on your paper to draw where the slices are. Draw like what we would get. So over here, I would use this top measurement. I would use that measurement, and I would use this front measurement for the dimensions of my shape. Then right here, I'd use how wide this is and how tall it is. So those are my 3 different ways that I can slice up my prisms. 2 options vertically, only 1 option horizontally because I cannot change that size. So think about these 3 examples right here. I want you to draw the shape and like the shape that you would get from the slice and then label the dimensions. So I'll help you with the first one. First one is standing vertically, so I'm going to try to draw it standing vertically. It would kind of look something like that. Well, what would this edge on the right here measure? Well, what were all the heights of the edges there? Well, how tall is that prism? 8, right? So this will be 8 inches tall. How wide is the prism? 10, right? Now wait, where's that 12 go to?
12 is the height.
Yeah, 12 is the length, like how deep it is into the page. So that 12 relates with this, which we don't care about that because my slice is chopping through that. So we don't care about the 12. We care about the 8 and the 10, and those will be my dimensions. So try your next 2 shapes. What will be the dimensions of those slices that we create? My next one will be flat. I'm going to kind of try to draw that. My next one will be standing. It's a little hard to draw with perspective. If you can't draw with perspective, just draw like a regular rectangle. But I'm trying to draw the perspective of if I drug my shape, and actually I can kind of cheat up here because I have the smartboard. So I can actually draw my slice right there and pull it out. And I can actually draw my slice right here. Ooh, except I need to stay parallel. And I can pull that out. So on that second one, anybody would tell me what those dimensions would be? Yeah, Cassidy? 12 by 10 because I see this edge right here will be the 10. And then this edge right here will be the 12. Then we know it'll be rectangular, so then, and of course those would be inches. Oriana, do you have a guess for the last one? What dimensions we would use? 12 and 8 because this is 12 and this is 8. If you are having issues on that, please identify that you might need some extra practice. So go to the back. Check out the got it there. What will be the shape that we get when we cut into that and what will be the dimensions of it? Sometimes you have to think about the dimensions first before we can think about the shape. When I look at what side I'm cutting through, what length, like what number am I cutting through, which means I'm not going to use it. What one am I cutting through? Bella?
You're cutting through a 5 centimeters.
I'm cutting through the 5. Notice this is my 5. I'm cutting through that, so we know we're not going to use the 5. So what 2 numbers will we use?
6 and 4.
The 6 and the 4. So when I draw this out, I know that I'm going to get a rectangle that is 4 by 6. Now actually, if I do this accurately to match the shape that they gave me, if I kind of cheat because I'm on my smartboard, The 4 would be along the front, and the 6 would be how deep it is. That's why it's kind of hard to look at it in perspective. There, my 6 looks shorter, but we know it would actually have to be longer. Now, what effect will it have if I slice like I have here and this got it? See the gray slice that I have running diagonally through that prism? So now, what if I slice diagonally? Well, if I take this shape, I'm going to trace over it. This is what I'm cutting. I'm cutting through it diagonally. Cutting through it diagonally. I still make a rectangle. Don't look at this triangle that you see formed by the cut. Look at what you cut. What I cut is a rectangle. What do I know? Eli?
When you cut a rectangle in half diagonally, it makes 2 triangles.
Yeah, but I'm not looking at what's left over. I'm just looking at this slice. Only look at your two-dimensional, like what is the part of the slice. So whether it would be the top of this bottom section that you made or the bottom of this top section that was made, we want to know what are the dimensions. Well, what would this edge right here, what would that dimension be? Abby? Yeah, it'd be 2. This would be 2, and that would have to be 2. Keep going, Abby. So if we did this slice, sure, I agree, it would be flat on the bottom. But because it's not flat, is this distance the same as that distance? No. So this distance right here is some distance bigger than 10. No.
Okay, wait. So if we did this diagonally, wouldn't it be half of the height cutting, like, each half range? Wouldn't it be third?
We would actually, you do not have to have this on your paper, Eli. Do you know how we would solve for that? So I'm going to drag this back over. We know that this side is 2. But now if I look at the triangle formed, I've got that top edge, and here I've got a 10, and I've got a height of 3, and this is what I'm wondering, is that edge, this edge right here, that's what I'm wondering. That is the hypotenuse of my right triangle. Thomas, do you know how to solve it?
I'd say Pythagorean theorem.
Which is, do you know it?
A squared plus b squared equals c squared.
So this side is c, and if I square it, that'll be equal to my other 2 sides squared and put together. So my 10 squared would be 100. My 3 squared would be 9. So c squared, that edge length squared, would actually be 109, which means that c, that edge length, would be radical 109. That's my length. Now, this is why I said you don't have to have this on your paper. That would be the length of this edge right here is radical 109. If you want to label it just so you have it, but what we need to know is it's bigger than 10. That's all we care about, is that it has to be longer than 10. Since it's not flat, it's diagonal. I took 10 and I squared it. 10 times 10 is 100. 3 times 3 is 9. I did it quickly because we don't really care about this right now. We're going to get more into Pythagorean theorem. I forget if it's next chapter or the chapter after that. We go a little bit deeper in triangles.
Are we going to do surface area at all?
Surface area? Yeah.
Dang it.
It's not bad, trust me. I've got a couple lab things we'll do. How we draw cross sections. Some of you will be really good at this. Some of you will struggle with this. We have to think about what sides of this shape can I physically see right now. You are not Superman. You cannot see through things, actually. But in math, we draw things as if we can see through them. So when I look at this prism right here, what sides, what faces, because we start to call the flat surfaces faces, what faces can I see? Isaiah?
You can see the top and the one that's facing towards us and the one that's going away.
I can see the top right here. I can see the front. And I can see the right side, right? Any of the other sides, I don't actually see. I just know they're there because it's a prism. We know about a prism. So when I draw my horizontal cross section, I draw solid lines on the faces I can see. I draw dashed lines on the faces I quote unquote can't see. So when we draw this horizontal cross section, is horizontal up, down, or left, right? Left, right. It's with the horizon. The sun rises on the horizon. So horizontal lines are like this. So I can see the front. I draw a solid line. Now when I go to draw my line on the next side, do I just, draw a straight line? How do I draw the line on the right side? Who's an artist? Who knows how to use perspective?
Kayla's an artist.
How do I determine the angle that I have to draw this line at? Like, what makes it look right?
Well, it's sort of drawing at an awkward angle. Like, it's hard to explain, but like.
Sorry, Oriana just stole it. Say it again, Oriana.
It's parallel to the bottom or the top.
So when you go to draw anything that's not your front, what's facing you, you have to be parallel with your other lines. Notice my top line here, this line, and my bottom line are all parallel to each other. Then I cannot see the back or the left, so I do a dashed line for the left, and I do a dashed line for the back. And notice your left edges have to work just like your right. They have to be parallel to the left edges. And the back edge has to be parallel to the back edges. If it doesn't look right, you haven't drawn it right. Your brain is really good at figuring this stuff out. So I hope that if I see you not drawing, that you're already done with this and already done with the vertical one. So I want you to try the vertical one on your own real quick. Remember, we can see the front, the top, and the right. I know, but now we're going vertical. So now I start vertically on the front because I can see the front. Then I can see the top, so I run back the top. My angle's a little off, so I'm going to fix that. Yeah, that's pretty good. Then I cannot see the back, and I cannot see the bottom. So you should have something like that. You could shift it left or right, and it would hopefully not change if all mine was grouped together. I could shift it left or right, and I'll still get the same sizes. Any questions on how we draw these? Eli?
I just wanted to say that if you look at it for a while, you can see that you can't actually tell which way it's facing.
Yeah, so this is one of those really fun things. I'm going to zoom way in just so I have some space to draw.
It hurts.
I just want space to draw. So this is where we get into when two-dimensional becomes three-dimensional. Find a space on your paper, probably off to the right there of the vertical cross section. Draw a square.
3D or 2D?
Well, 2D to start. I want you to draw another square identical to it, but wait, watch real quick. Give me your eyes. Do not do what I'm doing because I'm going to cheat. I have a smart board, I get to cheat. We're going to draw another square identical, except shift it.
Oh, I know what we're doing.
Then, when we connect my corners, my brain now goes ahead and says, wait a minute,
That's 3D.
this is 3D. Now, your brain's going to have a really hard time with what I just drew because my blue face is on top.
Oh my gosh.
See how your brain is like all like So I can, to fix that, make my face that's on top, make that my front face. So now my blue's on top. Now this should make your brain happier. Now I connect these, and now my brain should be okay to say, okay, blue's in front, green is the depth, and red is in back.
If you think red like think about red being
Yeah.
in front and you're still
So it's all about what you get your brain to do. Your brain can switch from thinking in 2 dimensions to thinking in 3 dimensions. I know. So I did that on purpose. Hey, hold on. Brennan, say what you said again.
It like distracts me because like all the colors are like pretty much all colors.
I wanted that to split. So if I do this again, but I use the same colors, it should be simpler. Now hold up. The other thing we do when we're drawing is if I can't see something, because I'm not Superman, if I can't see something, I go ahead and I make it dotted. So if I go back and I fix these things to dot what I cannot see. I cannot see those.
Life is so confusing.
Cannot see those. Now, it will also help your brain if you just erase everything that you can't see. Now your brain should be much happier. To say, oh, it's a cube. Okay. And then, if I draw these lines dotted, my brain likes that better because I know what's in front. I know the perspective that I'm supposed to have.
Look at the dotted corner, like where all of them meet. Just
Yeah.
look at that
Well,
for a second.
if you make a certain focal point. But all that to say, when we're drawing in 3 dimensions, it's all up to what you make your brain do. So you might see something differently than your classmate sees it. Questions? All right, now we got to move on. So, draw and describe. That's why we took a second to practice drawing. Draw and describe a cross section formed by a plane that slices the cube as follows. So, first one, plane is vertical, intersecting the left and right faces. Vertical, intersecting the left and right faces. Vertical, intersecting the left and right faces. Try this out. Because remember, vertical slices, we have 2 options. We have 2 ways. Actually, we have infinitely many options because we could spin it, we could keep turning it. But if we want to be parallel to the shape, we have options. Vertical, that intersects the left and right faces. So are you currently intersecting the left and right faces?
Yes.
Intersecting, so cutting through. So what we should really have here, I'm either going to do a slice like this from front to back, or a slice like this from left to right, because those are my 2 vertical options. When I think about those, the vertical option that I want to take that intersects the left and right has to go this way. So you should have something like that.
I did it the opposite way.
Then erase it and fix it.
Dang it.
You need to intersect the left and right faces.
Oh wait, no.
Because this side is my right side, and this side over here is actually my left
I
side.
feel like the top and bottom faces should be considered horizontal, because that's like really confusing.
They're horizontal faces, but we're making a vertical slice through the left and right
Like
faces.
the top cut, like of the slice, that should be considered horizontal.
That's a horizontal line, but it doesn't make for a horizontal plane. It makes for a vertical plane.
Oh, I get you.
So now we have to go horizontal. And horizontal, I only have one option. So the fact that it says intersects the front and back faces, will my horizontal slice intersect the left and right faces? Yeah. Will it intersect the top and bottom? No. It's horizontal. How could it intersect the top and bottom if it runs parallel to them? So this would be my slice. But remember, we have to dash whatever I can't actually see. So I'm going to draw the sides that I can see. And guys, I often make mistakes and have to erase because it doesn't quite look right. And then I dot my back line and I dot my left side. Doesn't have to be perfect, just has to look good. Not perfect, just good. So I always joke that my sister stole all the artistic ability because my sister's an artist, but I got all the math ability, and somewhere in between is mathematical drawing. Like, you don't need to be an artist to understand mathematical drawing. Actually, some of the best artists are bad at math because it's too rigid. It's too structured. So, the art class, I think it was the 8th grade art class, but they were just discussing M.C. Escher. Has anyone ever heard of M.C. Escher? He's one of the few mathematician artists. He is a guy who understands a lot about math and a lot about art. So if we get to the end of class, I'll show you some of his work. If you want to screw with your brain, look at M.C. Escher art. There's no up or down. There's no, yeah. All right, try the got it down here. Draw and describe. Which, guys, by the way, we forgot to describe up here in the example. If this is a cube, what would my cross section that I got here be? What kind of shape?
A cube. A square.
Square. When you have a cube, the length, the width, and the height are all the same. So no matter what way I turn it, it looks exactly the same. So no matter whether I slice horizontally or vertically, as long as I'm parallel with it, I'm just going to get a square. So here we want to notate this would be a square. And over here, when I cut horizontally, well, this would be a square. Now look at the got it. Draw and describe a cross section formed by a vertical plane that slices the front and back faces of the prism. So be careful. Vertical plane slicing through the front and back. So when it says through the front and back, first thing I do is I make vertical lines on my front and back. My front I can see, my back I can't see. And then I go from there. So go from there, connect those. I got to try to get this to capture. It's being kind of annoying.
Yeah, it should be like Siri.
A year or two ago, my students got like, because screenshotting was new, they would make the screenshot noise every time I captured. And it was whatever. I didn't care, but it was some of their classmates I think got annoyed. But like every time I would capture, they'd go. They're like, you know the noise when you take a screen capture?
With your iPhone?
Yeah, with your phone.
Wouldn't it be annoying if somebody like turned on their phone every time we captured and like screenshot it?
Yeah, I'm talking about this noise. So that's the noise that they would try to make every time. No, I just took a random screen capture. Alright, so first off, when I look at this got it, hey guys, back with me. When I look at this got it, what type of shape am I going to end up making? A rectangle, right? Because obviously I've cut through the front. I'm going down to the back and up to the front. So we get a very big rectangle. Now here is where your mind blows. Take a cube. Cut off a corner. Don't cut vertically. Don't cut horizontally. Cut off a corner. So what I'm saying is essentially cut through right here, right there, and right there to chop off a corner. I need to make one of these. Maybe I'll make one tonight on my table saw to bring in. But if we chop off a corner, it's going to be a diagonal plane, right? I have to cut kind of like this to chop off that corner. So I'm going to zoom in on this for a second and see if we can really draw this.
But that wouldn't really be a square.
We're not getting a square. It's saying describe the cross-section form. So what would it make when I chop off that corner?
No, pyramid.
Ooh, so I've heard two good things. I've heard somebody say triangle, and I've heard somebody say pyramid.
Triangle. Square. Pyramids are way better.
Square pyramid.
All right, check it out. Hold up. I'm going to use the corner closest to me.
Which one is that?
Oh boy. It will snap.
We good? Thank you. We're going to use the corner closest to me that I can see. And of course, all of this is, what do you mean closest to me? It's a piece of paper. This corner is sticking out towards me, and I can see it and I can work with it. I agree. I can do this corner either. So one of these corners, now I love that you say this because that's what I was trying to get us to get to. This corner, notice I can see all three faces. Let's work with the corner where I can see all three faces. Over here, that would be hard because one of the faces is behind the other ones. So we're going to use this top corner, and we're going to cut through here, and then through, I don't know, down to a point there, and down to a point there. So those should line up. Let's make this look a little prettier. Now, Bunger said, I'm going to get a pyramid. He says it's true because it's three-dimensional. Now, I don't have the right pyramid in here to really represent this. But this is just too steep. It's kind of hard to tell. But notice we have an edge. We have an edge right here from the top. We have an edge right here from the right face. We have an edge right here from the front face. We have three edges. And then if I took that off, I'd have it all coming up to a point. So I'd have a triangular base pyramid like this, just a lot less steep. This is a really steep pyramid. But think about the two-dimensional section at the cut. So if I connected these points and looked at, like I pulled this off and looked at what is left once I cut that section off, what's the 2D shape that we made? A triangle. So the two-dimensional shape that we actually pull off of here is a triangle. If you want to draw that on your paper for your reference, draw it on the right corner of this prism. You're going to draw a line across the top diagonally, a line down, and if you want good, like, if you want step-by-step directions, put a midpoint here, put a midpoint here, and put a midpoint here, and then connect them all. It's easier if you have points that you're trying to get to. Then you can see your triangle a little bit easier. It's just going to give you options for, like, if I do this cut of this shape, which of these is correct. So you won't have to draw it. It'll give you options. Yeah. Now I'm going to show you some Escher art, I think. DJ? No, he's an artist. Oh, so